In this video, we are going to see about paging. Paging is a memory management scheme used by the operating system to store and retrieve data from secondary storage efficiently. It avoids external fragmentation. So external fragmentation is a memory management problem where free memory is available but it is divided and it is scattered somewhere else. It is not contiguous, so it is difficult to store the data. But it is avoided in this paging. And breaking the physical memory into fixed size blocks are called frames. Breaking the logical memory into blocks of same size are called pages. So let me explain you what is this physical memory and logical memory. So see in this diagram we are having a CPU in the left, physical memory in the right, in between we are having a page table. So the CPU will be generating the logical address. So what we are giving in the code, that is the logical address. Okay, so here the logical address, it contains two parts. One it is P, that is page number. D is the offset, and this page number is indicating the frame number in the page table. So the page table contains the frame number, and this page table, it is indicating page number is indicating the frame number. Now this frame number is combined with the offset, and now it is generating the physical address. So this is a way the logical address is converted to the physical address. So now using this physical address, the particular location from this physical memory is found, and here we can store the data as well as we can retrieve the data. And so here we can see the example. So see the left side, that is the CPU, which contains the logical address, and the right side which contains the physical logical memory and physical memory in the right side. And in between here we are having the page table. So as I told earlier, the logical address from this logical memory is converted to the physical address so that the data can be placed in the specific address. And so see here, the pages, each pages will be having a frame number in the page table, and using that frame number the pages will be allocated in the physical memory. And here we can see the free frames before allocation and after allocation. So see here the free frame list is there, 14, 13, 18, 20 and 15, and these are the pages to be placed, page 0, 1, 2 and 3. And here these are the allocated frames. See here, come to the page table. So all these page number 0, 1, 2, 3 are allocated in the free frame list like 14, 13, 18, 20, and finally it is placed here. And it is noted that free frame list, that is 15, the last one, it is a free frame list, nothing is there to be allocated in that particular frame. And so if you are taking this paging, here we can find one drawback, that is time required for requesting and keeping the data there. So this particular problem is solved by one thing that is called a hardware support. That software is hardware is called translation look aside buffer. So it is associated to high speed memory. It contains two parts, a key and a value. And we can see the example. See here, the diagram is similar to the previous what you have seen in the first diagram. The same CPU and logical address and page number and physical address, physical memory. So what it is included, what is extra here, it is the TLB. See here, this is the TLB. So it is kept in between the logical address, physical address, or CPU and this page table. It is kept in between these two. And here it contains two column, one it is page number and frame number. So here from this logical address we will be getting the page number, and it is searching the page number here, and the frame numbers will be given directly. And so the data, the frequently used data will be stored in this TLB so that it can be accessed very easily. And here we can see two concepts, one it is TLB miss and TLB hit. If the requested frame is there, page is there, that is called a TLB hit. If the requested page is not there, it is called a TLB miss. If it is missed, again it has to be retrieved from this page table. Okay. And so here also we can see with an example like how the pages are allocated in the physical memory. So pages are starting from the 0 to 5, And here we are also having a page table. So instead of one, there are two columns in this page table. So the second column indicates the bit, whether it is a valid bit or it is an invalid bit. If the required page is there, it will be indicated as valid bit. If the required page is not there, it is indicated by I, that is invalid bit. So see here, it is indicating the valid bit and invalid bit. Here the pages 6 and 7 are considered as invalid bit because there is no page 6, 7, right? So 0, 1, 2, 3, 4, 5 pages are there and they are considered as a valid bit. So based on this page table, the data are stored or the pages are stored in the frames as it given in the physical memory. Okay, so that's all about the paging. So in this topic we learned about paging, and finally we came to know what is paging, how the data are stored, and how it is retrieved from the physical memory. And Also we have seen one drawback in this paging is time required to store and retrieve data, and it has been solved by one hardware support that is called translation look aside buffer. So it is kept in between, and it is making the work easier for completing the paging process. Okay, thank you.